Quantum computers versus supercomputers. What are they? You may have heard the terms supercomputers and quantum computers, but may not have ever gotten around to understanding what they are in their true sense. We know that supercomputers and quantum computers sound like very powerful computers, but exactly how powerful are they? And how do supercomputers and quantum computers compete against each other? Why do we even need such systems if they are this powerful? What kind of costs are we looking at? Welcome to another video of the Modern Day Geeks. Today, we're going to find out what is a quantum and supercomputer and what do they do. Supercomputers have been essential in advancing the boundaries of science over time. In order to create sophisticated AI models that can learn from trillions of examples, speak hundreds of different languages, seamlessly analyze text, images, and video together, create augmented reality tools, and more, Meta earlier this year launched the AI Research Supercluster, which is one of the fastest AI supercomputers. However, quantum computers were created as a result of the search for a faster computing device than supercomputers. Zhuangxi 2.1, the world's fastest programmable superconducting quantum computer, was unveiled by the University of Science and Technology of China last year. It is 1,000,000 times quicker than a traditional computer. That's right, 1,000,000 times faster than a supercomputer. Google debuted a quantum AI campus in Santa Barbara, California during the I/O conference last year. It included a quantum data center, research laboratories for quantum hardware, and chip fab facilities for quantum processors. Within 10 years, the tech giant hopes to construct a practical, error-corrected quantum computer. Future quantum computers will be quicker and more effective than supercomputers in solving complicated problems. However, does this indicate that supercomputers will soon be obsolete? Let's investigate. Let's have a brief look at the evolution of both of these technologies. In the 1960s, the first supercomputer was created. The creation of contemporary supercomputers, however, came much later, in the 1990s. ASCI-RED, Intel's first 1 teraflop supercomputer, was created in 1997. The Summit, an IBM machine that is now the second fastest computer in the world, is tripled in processing power by the Fugaku supercomputer at the Riken Center for Computational Science in Japan. A maximum performance of 442,010 teraflops have been recorded for the Fugaku. Now, as far as the quantum computer is concerned, Richard Feynman and Yuri Manin initially presented the idea of quantum computers in the 1980s. The first quantum computer was created in 1998. 2017 saw IBM make the first commercial announcement of a quantum computer. Let's hear it in the words of Srinjoy Ganguly, a senior data scientist. He says quantum computing has seen a major boost in the last 10 to 15 years. Companies worldwide are investing in various quantum technologies and making their quantum hardware. Today, we are in the NISQ, Noisy Intermediate Scale Quantum era, working on 100-qubit quantum systems. They may not deliver perfect results, read noisy and erroneous, but you can still work on them. However, we are still very far from achieving the maturity level to have a fully fault-tolerant quantum computer. Now, how does the functionality of both these technologies differ? The supercomputers we see today, whether they be IBM Sierra or Sunway Taihu Lite, run at a high compute-to-I/O ratio. What this means is that a supercomputer uses more processors than a typical computer because it is more powerful. One of the top 5 fastest supercomputers in the world, the Sunway Taihu Lite, contains over 40,960 processing modules, each with 260 processor cores. While a traditional computer uses binary, quantum computers use qubits, which have much more computing capacity and are subatomic particles like electrons or photons. Only a regulated quantum state, at temperatures below zero or in chambers with an extremely high vacuum, allows the qubits to function. Quantum computing, on the other hand, is predicated on 2 phenomena. Qubits' capacity for superposition allows them to do 1,000,000 calculations at once by being in several states at once. Qubits can't sustain their condition for extended periods of time since they are sensitive to their surroundings. As a result, long-term information storage is not possible with quantum computers. Quantum entanglement was defined by Einstein as EERIE activity at a distance. No matter how far away they are, 2 or more quantum systems can nevertheless entangle with one another. Gauging the state of one entangled qubit reveals information about the other qubit because of its correlation. The processing speed of quantum computers is accelerated by this special characteristic. Perhaps the most important question that can be posed in regarding efficiency, supercomputers are subject to the standard physics laws. The speed increases with the number of processors. Supercomputers are significantly less effective than quantum computers, which use quantum mechanics to do tasks. China has claimed to create a quantum computer in 2020 that is 100 trillion times faster than any supercomputer at doing calculations. A new energy-based benchmark for the quantum advantage has been developed by US researchers, and it has been used to demonstrate that noisy intermediate-scale quantum (NISQ) computers consume orders of magnitude less energy than the most powerful supercomputer while doing a given task. The topic of whether a quantum computer can execute calculations beyond the capabilities of even the most potent conventional supercomputer is becoming more and more important as supercomputers grow in size and dependability. This capability, known as the quantum advantage or quantum supremacy, is the turning point for quantum computers from scientific wonders to practical tools. However, assessing quantum advantage is challenging, as seen by the discussions that followed Google's September 2019 assertion of advantage for their SYCAMORE NISQ chip. SYCAMORE, according to Google experts, can solve a practical issue in just 200 seconds, but a powerful supercomputer would need 10,000 years to do the same work. A supercomputer could perform the operation in just 2.5 days, according to IBM physicists, who said this was a massive exaggeration 1 month later, thereby disproving the claim of superiority. Researchers are currently looking for problems that today's developing quantum computers can solve more quickly than the most potent conventional computers in an effort to benchmark the development effort. Calculating the output of random quantum circuits is one activity that obviously lends itself to a quantum computer, RQC. Google based its 2019 claim of quantum advantage on this benchmark. The essential question is whether the quantum computer solves the problem more efficiently than the most potent quantum simulator. The problem can be addressed by running a quantum simulator software on a conventional supercomputer. And now for the development and infrastructure cost. A supercomputer would cost between 100 million and 300 million to build. That's extremely costly, but still doesn't sound too bad for a rich organization. For instance, the Sunway Taihu Lite from China costs around $273 million US. The annual maintenance costs range from 4 million to 7 million USD. The cost of quantum computers, however, is prohibitive. Tens of billions of dollars will be spent on only the hardware components. To make quantum computers economically feasible, the price per qubit must be dramatically reduced. A single qubit currently costs around 10,000 US. Additionally, maintaining a vacuum or a sub-zero temperature environment where qubits may operate in a quantum state is exceedingly costly. While a non-quantum algorithm may be used on a quantum computer, a quantum algorithm, such as Grover's algorithm for searching an unstructured database or Shor's algorithm for factoring, cannot be used on a supercomputer. What about the applications of supercomputers? When dealing with huge datasets, both supercomputers and quantum computers are used. Let's examine some usage cases. Weather forecasting. A supercomputer generates the weather information we receive on smart devices. Supercomputers not only forecast rain in your city, but they also forecast hurricane paths, saving thousands of lives. The world's most potent supercomputer is being developed by Microsoft and the UK's Met Office as part of a £1.2 billion agreement agreed last year to improve readiness for catastrophic weather occurrences. Supercomputers provide light on intricate academic subjects. Experiments in the lab are costly and time-consuming, so it makes sense to recreate the laboratory trials using supercomputers. For instance, several supercomputers were used to globally combat the COVID virus and create vaccinations. What about the use of quantum computers? We are unable to conduct operations on a qubit at the moment that takes more than a few microseconds. The quantum data is destroyed as a result, making it challenging to employ for AI or other general tasks, according to Ganguly. A computer device called QRAM, which will enable storing quantum states for several hours, is now under development. Applications for quantum computers may be found in areas like medication development. To investigate drug combinations and interactions, quantum computers are employed. Drugs are often purchased through a costly and dangerous process called trial and error. Computational chemistry. Unlike supercomputers, Quantum computers concentrate on the simultaneous presence of 0 and 1, providing enormous computing power to effectively map the molecules. Cartography. Using quantum key distribution, quantum computers make it easier to have secure communications. There is a drawback though. In a recent message, US President Joe Biden urged federal organizations to use quantum-resistant encryption on their most crucial systems. The most commonly used encryption method, RSA, is built on 2048-bit integers. This encryption might be broken by a quantum computer. However, we don't currently have a quantum computer that can do this function. There you have it, a full-fledged comparison between supercomputers and quantum computers. Feel free to share your thoughts in the comments below. Don't forget to leave a like and subscribe. This has been the Modern Day Geeks, and thank you for watching.